Everybody, here is your momentum simulation lab that we're going to be looking at. So it's a collision lab, and you want to go to this website or the website that I linked in the Google Classroom assignment link, and we're going to be doing elastic and inelastic collisions, and you'll change this number in the app, but then you want to make sure that you read all the directions here. So make sure the 1D box is checked. Click on more data to expand the data table in part 1. Okay, so I'm going to go to the simulation here, and this is what it looks like. So you'll see this stuff here, and you'll click on this play button. Sometimes you might get an error or it says that Flash Player is not enabled. So you're going to go to the little lock in your Omnibar or your search bar up at the top, and you'll have to click Flash Player and allow. Okay, so sometimes you might have to go to site settings, scroll down, see if you can find that Flash Player. But you'll click on this, and then it will turn on the simulation here. Okay, so then you want to reference that lab sheet, and maybe you want to have this open in Cami so that way you can edit it while you're working on the lab. Okay, so we got to make sure the 1D box is checked, make sure it's 100% elastic collision. So I'm going to go back here, see if I can find where those are. So here is the elasticity. We're going to have 100% elastic collision. So that means that everything is conserved. All the momentum and all the energy is conserved. If I change this to inelastic, then that would mean that percentage of energy is conserved, and you'll lose momentum in the scenario to like friction or drag or something like that. So we want 100% elasticity. Okay, and we got to make sure that everything is clicked the way it's supposed to be. So here we can change the mass of each of them. We can change the position, the starting position. That also, you can change that by clicking and dragging. And it says click the 1D box, but I do not see that. So this is probably just a simulation that's in 1 dimensions anyways. Let's check this. So this is the more advanced one. So yeah, here's where you can click 1 dimension and 2 dimension if you wanted to be in the advanced simulation. Okay, so we're just going to go to introduction, and I think that that should be good enough for the lab here. So for the first one, 100% elastic collision between balls of equal mass. So we're going to make sure that they are equal mass. And it says complete the following data table for each of the balls before and after each trial. Perform 2 trials with 2 different sets of balls of equal masses. Okay, so you have trial 1 before you press play on the simulator, and then trial 1 after you press play on the simulator. So you'll have to do mass times velocity momentum of the beginning for both of them. So this would be your system before you start, and then this would be the system after we start. Okay, and since we're doing 100% elastic, our momentum before should be equal to the momentum after. Okay, so let's take a look at this here. So we want to change the mass of both of them. We'll just make them 1 kilogram. And the position is fine. That'll change if we change this around, right? But we want 1 dimension, so I can't move it up or down. They're just going left and right. And that shouldn't really matter much because we don't have anything lost in the system because it's 100% elastic. So we can change the position by this or by clicking and dragging. We can change the velocity of the ball by changing this or clicking this vector and dragging it forward or backwards. So you see those two that are kind of linked and they drag along. So let's just make it a nice number. We're saying we're going 1.5 meters per second. The other one is going 0. And then we can change the simulation speed if it goes faster or slower. Right now it's right about in the middle. So when I click play, and boom, I got that 1.5 meters per second. Okay, and you can see after you're done here that ball 2 has the 1.5 meters per second. So let's restart that. So before the simulation, I have mass times velocity, which gives me 1.5 kilograms times meters per second. And then the other one is mass times velocity, so it's 0. So my total momentum in the beginning is going to be 1.5. I press play, do the simulation, boom. In the end, this is the one that has 1.5 kilograms times meters per second momentum. So that would be my system in the end, and that can show that my momentum is conserved throughout the system because this is the one that receives that 1.5 meters per second. The position doesn't really matter. We could use kinematic equations here to figure out how long it's going to take us to go a certain amount of meters or something like that, but we don't necessarily need that. Okay, so you're going to do 2 simulations here, balls of equal mass, and then we are going to do 2 trials with 2 different sets of balls of unequal masses. So maybe one is going to be 1 kilogram and the other is going to be 1.5 kilograms, but you're going to do 2 trials for that. Okay, and then answer these questions. And then for this one, you're going to create 3 more scenarios using one totally inelastic collision, so 0% elasticity. Okay, so the other ones are going to be 100% elasticity. Okay, that would be the easiest scenario. But you'll make 3 unique different scenarios. So different masses, different velocities, they both can be going towards each other, they can be going away from each other, that kind of stuff. Okay? And then there's a summary at the end, so don't forget to do that. But that is your lab or your simulation assignment